Welcome to the bank. School is just starting and there are 4 girls here who've earned a lot of money from their summer jobs. I'm here to help them open their first bank account. How much did you guys earn this summer?
I earned $2,000.
I earned $1,500.
I earned $4,000.
Claire, how much money did you earn this summer?
$47.
At the bank, our annual interest rate is 3.5%, and I think you should all compound quarterly. What is your desired amount of money?
$2,200.
$1,800.
$5,000.
This is
$52.
an equation that will help you all. It's called the compound interest formula. You can solve for rate, initial amount, desired amount, compounds per year, or time. You'll all want to solve for time because it'll help you get to the desired amount.
So is this how I would do it? I would begin by having my rate 3.5%, my initial amount is $2,000, my desired amount is $2,200. I would compound it quarterly, but I don't know how much time it would take. You would begin by plugging in all the values into your equation. First, you start by dividing $2,200 by $2,000, which gives you 1.1. Then you would have 1 plus 0.035 divided by 4 to the 4x. X represents your time. This translates into 1.00875 to the 4x, which is equal to 1.1. To get the exponent down, you have to take the log of 1.1 as well as the log of 1.00875. Then you would divide the log of 1.00875 divided by the log of 1.1, which gives you 10.9402, which is equal to 4x. To find your x, you take 10.9402 divided by 4, which gives you x to be 2.735, which is about 3 years.
To solve this equation graphically, in y1 you would place your right side of the equation, which is 2,000 times 1 plus 0.03 divided by 4 to the 4t, and in y2 you would place your desired amount, which is $2,200. Then you would hit graph, which gives you your graph. While graphing, I would recommend that you press zoom so then you can find what zoom you would want. I prefer doing zoom fit because it usually gets all the graphing. To find your intersection point, you hit second calc, hit number 5, which gives you the intersect. For the first curve, you keep it on the left side of one of your equations, and then on the right side of your other, which gives you your intersection point, which is the exact same as if it were to be solved algebraically.
Grace, I think you should compound it every 4 months or every trimester per year, because it will take less time for you to get your desired amount. So my rate is 0.035, my initial amount is $2,000, your desired amount is $2,200. You're compounding it 3 times annually, and we're going to try and find the time. So first what you do is you set it up into the interest equation, and so the first thing you do is you divide by 2,000, and you get 1.1, and then once you solve 1 plus 0.035 divided by 3, you get 1.01166666667. So you take the log of both sides, log of 1.1 and log of 1.01166666667 to the 3rd t power, and you divide by that log. And when you divide by that log, you get 8.217 equals 3t. You divide by 3, and your amount of years to get your desired amount, $2,200, would be 2.74 years, less than 3 years if you compounded quarterly. Now Grace, if you wanted to solve this graphically, here's how. Your total that you want to get to is 2,200, so you enter that in y1. The right part of the equation, 2,000, parenthesis 1 plus 0.035 divided by 3 to the 3x power in y2. Now, when you graph it, you get a graph that looks like this. How to find the number of years is you go second, calc. You want to find the intersection between the two lines, so you go to number 5. First curve, enter. Second curve, enter. Guess, enter. And your x will give you 2.739.
So, since I want to compound 2 times a year biannually, I would do my numbers, which is the same rate, 0.035, $1,500 for my principal amount, $1,800 for my desired amount, 2 for n, and I don't know the time. So I plug in my values and start by dividing 1,800 by 1,500, and I get 1.2 equals 1 plus 0.035 divided by 2 to the 2x. So I would add these two together and get 1.0175 for my answer. Then I would take the log of both sides and divide log of 1.2 divided by log of 1.0175 and get 10.5092 equals 2x, because the exponent comes down with the log properties. Then I would divide 10.5092 by 2, and I'd get my number of years, which is 5.25.
To solve this equation graphically, the first thing you do is put in your right side of your equation for y1. So you do 1,500 times 1 plus 0.035 over 2, because I compounded biannually, and put the whole equation in parentheses to the 2x, and x is time. For y2, you put in your desired amount, and mine is $1,800. Then you hit graph, and I put the graph on zoom fit so you could see the entire graph and see the intersection. So that's the first graph and the second graph. To find the intersection, which is the amount of years it will take, you do second, trace, and hit 5 for intersect. You want your first curve to be on the left side, and then for your second curve you want it to be on the right side of the intersect. Press enter, enter a third time, and you get x equals 5.254639, which is the exact amount of years you got solving it algebraically.
Alright, let's see about me. We've got a rate of 3.5%. We've got my initial being 47, my desired 52. I'm compounding quarterly, and the time is the question of the day. So I'm going to start out by plugging everything in. And we're going to divide each side by 47, which gets you a nice 1.106382979 is equal to what was inside the parentheses. We're going to take a log of both of those. So we're going to take the log of 1.1063827 or 979 divided by the log of 1.00875, which came from our 1 plus 0.035 divided by 4. And once you take the log of this divided by the log of this, you're going to get a grand total of 11.604316662 is equal to 4t. Divide each side by 4, and you're going to get 2.901799155 years, or 3 to say it short.
Let's solve this equation graphically. In y1, we're going to put our goal, which is $52. And in y2, we're going to use the same formula that we used earlier. Just going to put it right in there just like we did earlier. And we're going to hit graph. Whoa, look at that graph. I think the answer is where they intersect. Second, to calc. Right down here, number 5, intersect. Make sure you're on the first curve. Press enter. Make sure you're on the second curve. Press enter. Nope, we do not want to guess. And our answer is 2.9010791 years. Whoa, the same answer we got in the other one. Yay!
So using this formula, to find my desired amount of $5,000, I'm starting with $4,000. I have a rate of 3.5%, and I'm compounding quarterly to find my desired time. So I plug all my values into the equation, so I have 5,000 equals 4,000 times 1 plus 0.035 divided by 4 to the 4t, and I divide both sides by $4,000, and then I get 1.25 equals 1.00879 to the 4t. And to bring the exponent down, I do the log of both sides and then divide by the log of 1.00879, and then I get 25.49 equals 4t, and then I divide by 4, and then my amount of years is 6.37.
For graphics, this is Mary. For Y1, you want to plug in 5,000, and then in Y2, you want to plug in 4,000, parenthesis, 1 plus parenthesis, 0.035 divided by 4, parenthesis, parenthesis, to the 4x power. Then you hit graph. Once you hit graph, you want to find the intersection of what that point is. So you go to second, trace, and then you want to hit 5 for the intersection. And then you go enter for first curve, second curve, and then enter again. And then your intersection is at 6.4.
I'm glad you all learned how to use the compound interest formula and you learned to spend your summer money wisely. Have a great school year!